And so with a logarithm, the base is always a positive number other than 1. And we see it written y equals log base a of x. Your base is just a subscript. It's a small number here. And what that means is x is equal to a to the y power. So you should write this statement down. That is the actual definition of a logarithm. Okay, so the logarithm is basically finding an exponent. This means a to what power would equal x? A lot of times when we talk about it, we'll draw arrows. We'll see a log and we're going to change it into an exponential. And so you start with the base. So the base of the log is the base of your exponential. Go across the equal sign, that's your exponent, and equals your x. And I'll do a lot of that in the next few examples. If we think about exponentials, if you take a positive number to a power, you always get a positive answer. So the domain of a log, your argument has to be a positive number. So x has to be greater than 0 when we're talking about our domains. So first thing we're going to do is just rewrite these by making sure we can go back and forth between exponential and log form. So this one is currently an exponential because it's written with an exponent. If I ask you to write the log, the base of the log is the same as the base of the exponential. Okay, in the exponential, your base is the number being raised to a power. In your log, you write that as a subscript. So it's just a small number there. You go across the equal sign. So it's log base 1.2 of m, and it's always equal to the exponent. So equals 3. If I have log base e of b equals -3, how would you write this as an exponential? Where would we start?
E to the -3.
Equals b. Because the base of the log and the base of the exponential are the same. Okay, take a second and try C and D for me. How would you write C? Three to the C power equals 5. And on D, it would be log base 3 of 9 equals 2. So if you draw in those arrows, it can help. But you always start the base of the log and the base of the exponential are the same number. Questions there? So for the next one. If I asked you to find the exact value, if you understand what a log means, you might be able to just look at this and tell me. The log means the exponent. It's saying 2 to what power equals 16? 4. If you recognize that, you can just write down the answer. If you don't, you could always set it equal to x. So your work, you would say 2 to the x power equals 16. This is like a question you would have had on your test. We would get a common base. Rewrite 16 as 2 to the 4th, and so x is 4. So I'm okay if you can look at it and tell me the answer, but if you can't, you have to work it out. All right, B. Does anyone know what the answer is just looking at that one? -3. If you don't, set it equal to x and work it out. It means 3 to the x power equals 1/27. Common base, 1/27 is 3 to the -3rd, so you get -3. What's the answer to C? Means 2 to what power equals 1? 1 is 2 to the 0 power. So we just get 0 for our answer on that one.
But wasn't there something about not being one? At the one logarithmic function to the base, they cannot equal.
The base can't be 1. So I can't say log base 1. I can't have it.
Because you can
Like
never make that
this.
equal anything, cause 1 to any power is
It's
still
still 1. Yep. Alright, D. 5 to what power equals 25? 2. Alright, can you solve those kinds of problems either looking at them and telling me what it is or writing it as an exponential and solving? So let's continue with these equations, but I'm going to change it a little bit. So what if I said log base 3 of 4x minus 7 equals 2? How would we write that? If I went this.
Your 4x minus 7 over and FOIL it, like square it.
Well, let's write it as the definition. So you would start with your base, which is 3, to the second power equals 4x minus 7. So 3 squared is 9. Add over our 7. Divide and x is 4. You do have to check on these, but all you really have to verify, the argument has to be positive. So all I need to check is if I put a 4 in here, is 4 times 4 minus 7 a positive number? Yes. If it wasn't, then I would have to say there's no solution on this problem. Okay, for B, log base x of 64 equals 2. How would I write that as an exponential?
x squared equals 64.
How do you, yeah, to get rid of a square, you square root. With that, we always do plus and minus, so we get positive and negative 8. But on a log, the base and the argument both have to be positive numbers. The only thing that can be negative is what it's equal to. So I can't have positive 8, or sorry, I can't have negative 8. Positive 8 is the only answer that works here. And that's from that first slide when we talked about the base. I said the base has to be a positive number other than 1.
But there's no argument, so we don't have to worry about checking.
Correct. The argument is 64, so even if I plug in an 8, it doesn't change that argument.
The argument is the second
Mm-hmm.
number. What's the first number called? No, x. What is x called?
This is
The base.
the
argument,
base,
And then
the argument, and then what it's equal to, which is really like your exponent. All right, I'm going to put a couple up here, and I want you guys to solve them. Take a few minutes and see if you can work out all of these. Alright, so if I change them to exponential, this will be x to the negative 2 equals 16 over 9. How'd you guys solve it from here? There's a few different ways, so that's why I'm asking. Okay. So what he did is square root to get rid of the square, and that would throw a plus and minus on. So you get x become to a negative 1. Square root of 16 is 4. Square root of 9 is 3. Did you just take each side to the negative 1 and flip this over here, or did you?
I got, x equals 3 to the 4.
Mm-hmm. So to cancel that, you could take each side to the negative 1. So that's x next to the positive one. That would flip it 3/4.
Yeah, I guess I didn't work it out completely like you.
Yeah, but you knew what you were doing.
Yeah.
The other option, x to the -2, you could have wrote that as 1/x². And cross multiplied and solved, so several different options. Are both of these answers possible?
Just the positive answer.
No, that doesn't mean your answer has to always be positive. For instance, if the equation had log of base -x, then the -3/4 would have been the one we kept. So do make sure you're actually plugging those in, not just thinking that your answer can't be negative. B, and that's 16 to the 3/4 power equals x, so that means the 4 through the 16 cubed. 4 through the 16 is 2, 2 cubed is 8, so you should have gotten 8 for that one. This one we would have 36 to the x power equals the square root of 6. Common base, 36 is 6 squared to the x. Square root of 36 is 6 to the 1/2. So 6 to the 2x equals 6 to the 1/2. So 2x is 1/2 and x is 1/4. How are we doing on these? Do we need more problems like this? Okay. Couple more things I want to talk about today. The first one, sometimes I'm going to ask you to evaluate logs, and we will use our calculators for that. So you can do it on either calculator. There are ways to go in and change the base, but right now, if I'm asking you to evaluate, I'm either going to be giving you a log base 10 or a natural log. So if you have one of these, it's right under the green. There's log and ln. That log is meaning log base 10, so if it were a different log, you couldn't use it. On the graphing ones, it is down towards the bottom. So there's log and then ln, right above that. So I just want to throw a couple up and make sure we can plug them in our calculator. They're going to be nasty decimals, so in general I say give me 4 decimal places. So if I said log of 46, so you just push your log button, type in 46, give me 4 decimal places, what did you get?
1.662. We round up.
Yeah.
1.6628.
Yes. Notice there is no base written here. When there's not a base, it's understood to be a 10, and that's the one we can do on this calculator. If it says ln, that's referred to as a natural log. A lot of times those might have e's in them. They don't have to. But we would do the ln 8 times. To get the e, you have to do second the ln button. And you should get 8.0794. So everybody got those?
So we really probably need to change the base,
Um,
or we just learn how to do that in the future.
we'll learn how to do that in the future. All right, where we are going to end today, we're going to write down some properties of logs. I'll use them for just a couple examples today, and we'll pick up with it tomorrow. But first, you need to write it down in your notes. So, properties of logs. These do require you to have all of the arguments have to be positive. The base can't be 1, so that's just kind of our assumption anytime we're talking about logs. So we have a product, quotient, and power property. Product property tells you if you have the log of 2 things being multiplied together, you can break it apart and add the individual logs. It kind of is related to exponentials. Like if I said 2 to the 3rd times 2 to the 4th, what do you do with those exponents? Add them. So that's why if things are multiplied, it gets broken apart into addition. You want to write these down. We will be using them to end today and to start tomorrow. Quotient property, if you have a log of things being divided, we subtract them. Just like if I said 2 to the 7th over 2 squared, you subtract your exponents. And the last one, the power property. If you have a log with something to an exponent, that exponent can come down in front. Two other things that we need to know with logs. The log and the exponential are really inverses of each other. They cancel one another out. So if you ever have a base of an exponential and a base of a log that are the same, they really cancel each other. What that means, if I had like 4 to the log base 4 of 7, I could say, well, the 4 and the log base 4 cancel each other, and my answer is just 7. Or if the log is first, if I had log base 4 of 4 to the 7th, okay, those cancel each other and equals 7. Or you could even think of this using your properties. That exponent comes down in front. This is 7. Log base 4 of 4. 4 to what power equals 4? 1. And you get 7. So a couple ways to think about it, but if you have a base of an exponential and a base of a log that are the same, those cancel one another. So what I'm going to do is look at just a couple examples with these two, and then we'll use the product quotient and power properties tomorrow. I just really wanted to get those written down in our notes. Let's look at these. So if I say 2 to the log base 2 of pi, you could set this equal to x and try to work it out, or you could recognize what's the answer going to be? Pi. Because the 2 and the log base 2 would cancel one another. You just get pi. If I said log base 0.2 of 0.2 to the negative square root of 2, what's my answer?
Negative square root of 2.
Because the base of the log and the exponential are the same, so that stuff all cancels. Log base 3 of 3 to the 71. 71. Okay, we'll use the other properties tomorrow. You guys have some time left. There is a handout posted on Google Classroom for you.